Hi, I'm Calliope Meadowshills,
And I'm Emma O'Boy.
and this is how you do the Pascal's triangle.
Hey, how's the math homework going?
I cannot find the answers to any of these problems. Like, how do you find 2 to the power of 5, 2 to the power of 9, and 2 to the power of 6?
I know this really cool way. It's called the Pascal's triangle. I'll show you how to use it. There's a bunch of different patterns and tricks that you can do with it.
And this will help me find the answers to these?
Yep, just keep watching. So the first row is row 0. It starts out with 1, and then from there it goes row 1, 2, and so on.
So the sides are always bordered with 1s, and to actually make the pattern itself, you have to add the numbers, and in the middle is the sum of the two numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. This adds the new row, which is row 3. It's just going to keep getting bigger because it can go infinitively with all the numbers.
This is the hockey stick pattern. The definition is the sum of numbers is equal to when you start with any one on the outside, and go diagonally down and then off to one side. And off to one side is depending on which way your diagonal is.
To properly use the hockey stick pattern, if you go at any diagonal and you go off to the side, that number will be the sum of all the numbers before it in the diagonal. In this one, you go from this diagonal, 1 plus 8 equals 9.
This is the power of 11's rule. The definition is a rule that says that each row reads a power of 11, starting with 11 to the 0, and going up by 1 in the powers digits row after row.
So 1, which is 11 to the power of 0, equals 1. 1 and 1 is 11 to the 1, which equals 11. 1 to 1 is 11 to the 2, which equals 1 to 1, which is the numbers just combined. And this goes so on until you get to 11 to the power of 5. This is an exception in the 11 power rule. I will show how this is used. This is an example of an exception. So in the 11 to the power of 5, this is 1, 6, 15, 20, 15, and 61. 1 stays the same, 6 and 1 are added, and that equals 7. 5 and 2 are added, and that equals 7. 0 and 1 are added, and that equals 1. And then 5 stays the same, and 61 stays the same. This gives you the number, which is an exception. This is also used until you keep going down. It keeps changing, and you use that method to have the 11 power rule. This is the Fibonacci sequence. The definition is, sequence is found by adding the numbers in the specific diagonal.
It has to do with the diagonals and the triangles. So it starts out with 1, and this row of diagonals is just one number, 1. So the sum of that row would be 1. And so like this row, it doesn't start with a number, but it ends with 1. So the sum of this diagonal would be 1. For the next diagonal, it starts with a number and it ends with a number. So the sum of this diagonal is 1 plus 1, which is 2. And you can also get the sums of the next row, like if we wanted to find 3, but we didn't want to add these up. You could do the 2 diagonals before, so we figured out that was 1, and the next one was 2. So you can add these 2, and you would get the next one. This is the powers of 2 rule. So the definition is the sum of the rows in Pascal's triangle are equal to the powers of 2. Starting with 2 to the 0 and adding 1 to the exponent as you go down each row. So going back to your question, Calliope, this is how you figure out the powers of 2 in the Pascal's triangle. So as you can see, we start with 2 to the 0, which is the row 0, so that's why 0 is in the exponents, and 2 to the 0 is 1. So if we go down the triangle, you get the same thing. You get 2 to the 1, and this is row 1, which is why that's in the exponents, and 2 to the 1 is 2, and if you add these, you get 2. You know how to figure out 2 to the 9, right? Since this is row 9, 9 would be in the exponent, and you would add all of these numbers together, and you would get 512. And that's how you use Pascal's triangle.
Okay, thank you. This will help me so much. So I'm going to draw it out. Can you make sure I'm doing it right?
Yeah.
Okay, so it starts with 1. So then I can use Pascal's triangle to figure out these 3 problems. 2 to the 5 is 32. 2 to the 9 is 512. And 2 to the 6 is 64. Hey, now that I'm done with my homework, do you want to play heads or tails with me?
Yeah, sure. Did you know that you can use Pascal's triangle to figure out the probability of each flip?
Awesome! Now I can beat you! Before we started researching, we knew of a few patterns in the triangle. While researching, we found many more interesting sequences. It is not just a triangle, it is one of our new mathematical tools.
It helped us understand math concepts such as probability and patterns, which is mostly in the statistics branch of math. We are excited to find new patterns throughout our math careers.